Hello friends, in this video today we are going to discuss about electromagnetic wave in conducting medium. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT 123. This is my Insta ID. You can follow me on Insta. So now let's start. Okay, first let me clean this place. Okay, so here is the topic. So we know the Maxwell equations are, Maxwell's equations are. So what are the Maxwell equations? We know divergence of D, which is a displacement vector, right, is equal to rho, and divergence of magnetic field vector B, that is equal to 0, and curl of E, that is equal to minus del B by del T, right, and curl H is equal to J plus del D by del T. So these are the Maxwell equations we know. Let me take this as equation number 1, suppose. Okay, so let's just I'm not going to give the equation number here. Okay, so let's keep this way only. Okay, now for conducting medium, so now you see, in case of a conducting body, when you give charge on it, then the charges reside on the surface of this conducting body, and inside the conducting material, the charge is equal to 0. So that's why this rho, that is charge density, gonna be 0 in case of conducting medium, right? So hope you have understood this. Now you see, so what we're gonna consider here in this case, right? So we're gonna consider a conducting medium, right? First let me write the meaning of the symbols that I have used here. So here this D is nothing but electric displacement vector, then rho represents charge density, just give me a second. Okay, charge density, actually it is volume charge density. Okay, volume charge density. Then this B is magnetic induction, and this electric field E, this is electric field vector, electric field intensity, right. Then this H is the magnetic field intensity, right. Now you see, in case of a conducting medium, so let us consider a conducting medium. So let me scroll down the page. Okay, just give me a second. Okay, let me add one more thing. This J represents current density. Now you see, for conducting medium, for conducting medium, this rho will be equal to 0, because inside a conductor there will be no charge, because all the free charges reside on the surface of the conductor. That's why, so inside it, that's gonna be 0. So that this rho is equal to 0 in this case. If rho is equal to 0, then we can write the Maxwell's equations for for conducting medium. For a conducting medium, let me do one thing. Let me write one more thing. Conducting medium of or you can say characterized by permittivity epsilon and permeability mu. Let me write this one within bracket, permeability mu. So for conducting medium, which is characterized by permittivity epsilon and permeability mu, this charge density, volume charge density rho, that's gonna be equal to 0. Therefore and one more thing, we can write this D vector is equal to epsilon times E, and B vector can be written as mu times H, and this J, current density, that can be written as sigma times of electric field E, right? That's what we can do. Okay, so now you see, so if we rewrite the Maxwell's equations, so what we can do here, you can see that in this case this rho will be equal to 0. That's why we're gonna write this 4 equations again, Maxwell's equations. Let me copy these equations and make a duplicate here. Okay, so now you see, let me scroll down. So here you see this rho will be equal to 0, right? So these are the Maxwell's equations for a conducting medium, right? So hope you have understood this. Now let me give equation numbers. Okay, so now you see, this is suppose equation number 1, this is suppose equation number 2, and this is suppose equation number 3, and this is suppose 4. Here let me mention one more thing. This sigma is nothing but conductivity. Okay, sigma is conductivity, right? Now you see, so what we're gonna do, taking curl of equation number 3. Okay, so if we take curl on both sides of this equation number 3, then what are we gonna get? So we're gonna have curl of E, and on the other side minus del T of curl of B. That's what we are going to have. Now you see, here let me use the black. Okay, so curl of E. In this case, what we can do here, now you see, so that's one gonna be equal to uh, we're going to use the vector identity, that curl of a vector, gradient of divergence of that vector minus, you know, del square of that vector, right? So if we apply the identity, that is curl of a vector, right, that is equal to gradient, you know, gradient of divergence of that vector minus then del square of the vector. Okay, so if we apply that, so then in this case the vector is e, so that's why this a gonna be equal to simply e. So let me replace the a by e. So if we do that, then here it will be e, and this is divergence of e, and minus that del square of e vector. That's what we're gonna have using vector identity. So on the other side, what we're gonna have, sorry, so that means, so this is replaced by this result, right? So then this equation implies that just let me clear this. Okay, equal to minus, now you see here one more thing what we can do here. We know that b is equal to mu times of h, right? So we can write here mu outside it. Okay, then del t of curl h, that's what we can write. Okay, so hope you have understood this. Now you see del cross h is nothing but equal to this. So using equation number 4, we're gonna have what we're gonna have, just this implies, let me scroll down. Okay, just wait. So now you see in this case this e dot del dot e, that's going to be equal to 0, right? That's going to be equal to 0. If this is 0, right, if this is 0, then what we can write, we can write minus del square minus del square e is equal to minus mu times del t, and instead of del cross a, so we're going to put this. Okay, so that is z plus del d by del t, right? So let me write it properly, del d. Okay, that's what we're going to have using equation number 4. That's what we have got. Okay, now you see this d is nothing but epsilon times of e, right? This is epsilon times of e. So we have already mentioned here, you can see this is, we have already mentioned. So if we use that value here, then what we're gonna have, minus del square e is equal to, so mu here we are to get, you see, this j can be replaced by sigma e. Okay, so that's why what we're gonna have, that del t here, we're gonna have sigma e vector plus, and d is nothing but epsilon times of e, so epsilon del e by del t. That's what we gonna have, right? So now if you simplify this, then what we're gonna get, del square E vector minus sigma mu del E by del T, then minus epsilon mu del square E by del T square is equal to 0. That's what we have got. So let me take this is suppose equation number 5. So let us suppose this is equation number 5. Similarly, if we take curl of equation number 4, okay, then we can obtain similarly taking curl of equation number 4, what we're gonna have, this equation. So both equations are similar, but here we're gonna get in terms of h. So just like the above equation, we're gonna get del square h minus epsilon mu times just let me write this way, sigma mu times del h by del t, then minus epsilon mu times second order derivative of h with respect to t. That's what we're gonna have, right? This is suppose equation number 6. So this is suppose equation number 6. This one is equation number 6 and this is equation number 5. So hope you have understood this up to this topic. So now you see, let me tell you one more thing. You see, so I have already told you that this divergence of E is equal to 0. So why it is 0? Because you see, as I have already got this equation, divergence of D is equal to 0 for conducting medium and D is equal to epsilon E. So from these two equations, we can write epsilon times of divergence of E is equal to 0. So it is here divergence of E is equal to 0, right? So hope you have understood this. It's very simple, right? So now what we are going to do next step. So now you see, this equation are, you can see that second order differential equations, and we can if the equation is of this form, then we can assume the solution of this equation. Okay, let us assume the plane wave solutions of Maxwell's equation. Let us assume the solutions of the form E vector is equal to E naught e to the power I k dot r minus omega t, and similarly H vector is equal to H naught e to the power I cap k dot r vector minus omega t, right? So where this k is propagation vector, and this k vector is equal to k into n cap. N cap is the unit vector, along k vector, right? So hope you know these things. So now you see, okay, now if we use this let me take equation, give equations number, so just give me a second. This is suppose equation number 7, and this is suppose equation number 8, right? Equation number 7 and equation number 8. So using this equation number 7 in equation number 5 in this equation, right? So let me use another color. So we're going to use this equation number 7 in equation number 5 in this equation. So what we're going to have now, you see, so let me scroll down the page just a bit. Okay, so substituting equation number 7 in equation number 8, not 8, sorry, equation number 5 in equation number 5 in this equation. Okay, so we have used this equation in this equation, you can see, right? So if we do so, then we gonna have that del square E, that's gonna be equal to minus this is minus, okay, so just let me write here, equal to, here we're gonna get minus k times E, then we're gonna have second order derivative of E with respect to time t, with respect to time t, that's going to be equal to minus omega square times E vector. So what does it mean? So it means here that we can write del operator instead of del operator. We can write here, we can use here this minus ik. Okay, when you square it, that's going to be minus k square, right? Simply here it's supposed to be k square. Okay, and this del t, that can be written as minus I omega. Okay, so how we have got this, I have already explained in the video where I have explained electromagnetic wave in isotropic dielectric medium. Okay, so if you have watched that video, that explained in the video where I have explained electromagnetic wave in isotropic dielectric medium. So if you have watched that video, then you have already got, I have already shown how we have got this. Okay, so if you don't know, if you want to know that how to get this, just watch that video, just search electromagnetic wave isotropic dielectric medium by Lekajit, then you're gonna get that video. Okay, so here we don't need to explain each and every term here, just we're gonna use directly this. Now you see, if we use these results, instead of del I, if we use I k, and instead of del t minus I omega, then equation number 5 will be of this form. So let me write that gonna be minus I k square E, then okay, minus epsilon, sorry, not epsilon, sigma mu, instead of del t we gonna use minus I omega times E vector, right? Then minus epsilon mu, instead of del t we're gonna use minus I omega whole square E vector is equal to 0. That's what we're gonna get. Let me scroll this page here you see. So this implies, so here we can cancel E, right? So and if we simplify this, then we're gonna get minus k square then plus sigma mu here we supposed to write I omega, then squaring this we're gonna get minus omega square, then this minus again it's gonna be plus, right? So plus epsilon mu omega square is equal to 0. This is what we're gonna have, and from this equation we can write that k square is equal to epsilon mu omega square plus I sigma mu omega. That is what we have got, right? This is nothing but it is an imaginary, right? Here we have got this I, that means this is imaginary. So this is what? This is imaginary. So let me use the black ink. This is imaginary. So that's why this k can be expressed as, if it is imaginary, then we can express k. Therefore this k can be expressed in the form of a complex number, that is k is equal to alpha plus I beta, right? So now you see, squaring both sides, what we're gonna get, k square is equal to alpha square plus 2 alpha I beta minus I square gonna be minus 1, so here minus beta square. That's what we're gonna get. That means we're gonna get, we can write, separating the real and imaginary part, we can write k square is equal to alpha square minus beta square, and the imaginary part is I 2 alpha beta. That's what we're gonna get. So now you see, let me take this is suppose equation number. What was the last equation number we have taken? Let me go upward. This is 8, so let me take this equation number now 9. This is equation number 9, and this is suppose equation number 10. Now comparing the real and imaginary part of equation number 9 and 10, comparing the real and the imaginary part, on the right hand side of equation number 9 and 10, then what you gonna get? So both equal to k square, right? So that's why this part is real part. Here the real part is this one, right? What we're gonna get? So alpha square, that's gonna be not alpha square minus beta square, that's gonna be equal to epsilon mu omega square, and the imaginary part is this 2 alpha beta. So here this is the imaginary part, so that's why 2 alpha beta, that's gonna be equal to sigma mu omega. That's what we have got, right? So hope you have understood this. So now let us solve these two equations. How to solve these two equations? So from this equation, what we can write? We can write that beta is equal to half of sigma mu omega by alpha. That's what we can write. So using this in this equation, then what we're gonna get, alpha square, instead of beta we're gonna write half sigma mu omega by alpha, here it's gonna be whole square, is equal to epsilon mu omega square. That's what we have got. So what we have done here, just let me give equation number. This is suppose 11, this is suppose 12. So solving 11 and 12. Okay, 11 and 12, solving 11 and 12. That's what we have got. Okay, now you see, so if we simplify this, then this can be written this way. If we multiply each and every term by alpha square, then we're gonna get alpha to the power 4 minus here, this is sigma square mu square omega square by 4, this alpha square. Then again, if we multiply alpha with the alpha square with the alpha square, then we're gonna get alpha to the power 4. Oh sorry, here when you multiply alpha square here and here, this alpha square will be cancelled with this alpha square, right? So hope you have understood this. So that's why what we have got on the right hand side, we're gonna get again alpha square epsilon mu omega square, and this is nothing but, you can see clearly, this is in the form of quadratic equation. Let me show you how. Sigma square mu square omega square divided by 4 is equal to 0. Now you see, this is in the form of quadratic equation. A x square plus bx plus c is equal to 0, because here you see this alpha to the power 4 can be written as, you know, alpha square whole square. Now compare this one with x square, so here a is nothing but 1. Okay, similarly, then minus, instead of b we can write this part, sorry, not this one, this part. So here alpha square will be taken as x in this case, right, minus this mu omega square. So this alpha square is taken as now x, compare with x, then the remaining part is constant. So if that is the case, then what we can do, then we're gonna use the quadratic formula. So I don't think I need to remind it. Hope you all know that quadratic formula, that is x is equal to minus b plus minus root over b square minus 4ac divided by twice a. We're gonna use that one. So if we use that one, then we're gonna end up getting that alpha square is equal to so minus of minus epsilon mu omega square, right? So that means it's gonna be epsilon mu omega square. That's what we're gonna have. Then plus minus root over b square is epsilon square mu square, then omega to the power 4, then minus 4ac, that is minus 4ac. A is here 1 and c is here this one, so there is already minus, so it's going to be plus, then minus minus, it's going to be plus. And if you multiply this one with this 4, then 4 will be cancelled, so then the remaining term will be of this form. Then we're going to get here sigma square mu square omega square. That's what we're going to have, divided by 2. So now you see, so what we can do, epsilon mu omega square plus minus, we can take that epsilon square mu square omega to the power 4 common, then inside it we're gonna get 1 plus sigma square epsilon square omega square. That's what we're gonna have. Okay, so divided by 2, then you can take the square root of this. Okay, then we're gonna get epsilon mu omega square plus minus again epsilon mu omega square after taking square root. Then here under root we're gonna get 1 plus sigma square epsilon square omega square. That's what we have got, divided by 2, right? So now you see, this is nothing but alpha square. Okay, now you see what we can do from here. If you simplify this, that's gonna be equal to, you can take this part common, right? And doing so, what we're gonna get, epsilon mu omega square by 2, and within bracket we're going to have 1 plus minus, then again root over 1 plus sigma square by epsilon square omega square. That's what we're going to have. So now therefore alpha will be equal to epsilon mu omega square by 2. If you take square root, then here it's going to be equal to omega root over epsilon mu by 2. So when we remove this square, then we should take a square root, right? Then 1 plus minus root over 1 plus sigma square by epsilon square omega square. This is also under root, that is power is half here. So what does it mean? Here you see, now this part is obviously greater than 1, right? So if it is greater than 1, then we cannot take here negative, otherwise it will be imaginary. So alpha should be a real number here. So that's why we're gonna take the positive only, okay, though we are getting plus minus here. So hope you have understood this, right? So now you see, okay, if we get this alpha, similarly we can obtain the beta as well, similarly. So we don't need to show it again. Similarly we can obtain beta is equal to, so same kind of result, but here you see what will be the difference. There will be minus sign in case of beta, okay. That's it. Omega root over epsilon mu by 2 within bracket minus 1 plus root over 1 plus sigma square, that is not alpha, sigma square by epsilon square omega square. That's what we have got, whole to the power half, right? So you can check yourself. If you simplify this equation for alpha instead of beta, and if you put that alpha value of alpha here, then you're gonna get this result, right? So hope you have understood this. So we have got alpha and beta also. Now you see, equation number these equations, you can see the equations, the solutions that we have considered. This equation number 7 and 8, okay, equation number 7 and 8 that we have considered, we can replace this k by n k cap, right? K n cap, and k can be replaced by alpha plus I beta, right? If I am not wrong, then k can be replaced by alpha beta, because k is imaginary, that we have already shown. Okay, so here you see, just you see, so what are the solutions we have considered? We have considered that E is equal to E naught e to the power I k dot r. I am writing it again instead of going upward frequently, so let me write this one again. So h is equal to h naught e to the power I k dot r minus omega t. Here you see, this k, this propagation vector, is nothing but k n cap, and k that we have considered that is equal to alpha plus I beta, right? This is complex number, right? So that's why we have taken, this is 7, this is 8. So therefore from the equation number 7 and 8 can be written as this equation number 7 and 8 can be written as this way. E vector is equal to E naught e to the power I, within bracket, instead of k we're going to write alpha plus I beta n cap dot r minus omega t, right, minus omega t. So here let me tell you one more thing, don't consider these two, this is page number here, okay, don't write this one, okay. Then h naught, sorry, not h naught, h, let me scroll down a little bit more. So h naught, h is equal to h naught e to the power I, again instead of k we're going to write alpha plus I beta, then n cap dot r minus omega t. So if you simplify this, then what we're going to get, so let me clean these things. So this is nothing but E naught e to the power minus I beta, sorry, not I beta, minus beta actually, minus beta, right, that's going to be e to the power minus beta n cap dot r, then e to the power, that means if you simplify this, right, if you open the bracket, then e to the power I, here we're gonna have alpha n cap dot r minus omega t, that's what we have got, right. Okay, so if you multiply this one with this one and this one, then again if you multiply I, then we're gonna get this, right. So similarly from here h naught will be h naught e to the power minus beta n cap dot r e to the power I, e to the power I, and within bracket alpha again n cap dot r, right, minus omega t, that's what we're gonna have. So let me take this as equation number, what was the last equation we have taken, let me check the equation number 12, right. So let me take this as equation number, okay, this is equation number 13 and this is equation number 14. So from 13 and 14 what we have got, you see, so the term here, this term minus beta, okay, what does it mean here, the term e to the power minus beta n cap dot r indicates that the field amplitudes are, you know, especially sorry, that's supposed to especially, so what does it mean, it relates it represents space and position actually, okay, this term attenuated. So that means, so when the electromagnetic wave enters in a conducting medium, the amplitude will be decreasing, okay, and it can, it will able to penetrate up to a certain depth, which is called skin depth, that will be discussed in the next video, okay, we're going to discuss it in the next video. So now you see here, just let me write it properly. Sorry. So this beta is called absorption coefficient. So beta is called absorption constant, right? So hope you have understood this. So in the next video we're gonna discuss about skin depth. Okay, so see you in the next video. If you like my video, please do subscribe the channel, hit the thumbs up button, also share with your friends and inspire me to create new contents for you and help me to grow my channel.